Okay, thank you very much. So I'm really glad that Jeff gave his talk before, because PBO, COCONet is in some ways an extension of PBO. It's an extension of the Plate Boundary Observatory into the Caribbean, and is sort of the first step of the concept of a network that would span all of the Americas. It is a 5-year project. We're entering the 5th year of the project, and there's a large group of people who are involved in it. I'm a representative from UCAR, Megan Miller, the president of UNAVCO, Glenn, Carl Feaux, Linda Rowan are all involved from UNAVCO, Bob Wang at the University of Houston, and Peter Femina from Penn State have all been significant contributors to what I'm presenting within this presentation. And this is not really describing the infrastructure so much, but how an infrastructure project can be used to build capacity and partnerships in international situations. So COCONet is really a multidisciplinary project. It's looking at natural hazards throughout the region, throughout the Caribbean, Central America, North Andes. It is really looking at the basic geodynamic and atmospheric dynamic processes that are the most important and most significant to that area. Primarily, this includes earthquake hazards, tectonic deformation, climate variability, and severe weather such as hurricanes. One of the main concepts of COCONet is to extend the idea of open data and open data products into the Caribbean and Central American community to promote the idea that open data benefits everybody. It benefits researchers, it benefits local users, and it benefits the society in general. And that is a very strong component of COCONet. It is designed to be, it is a large-scale project. It's designed to provide synoptic scale, so basically infrastructure so that people can leverage what COCONet is, so that they can have more focused investigations for their own research projects. One major component of it is to build capacity in the region, and that through developing international partnerships and connections. So just as a general status, this is a map that came out of one of the COCONet workshops. The original idea of COCONet was to establish 50 new continuously operating GNSS stations in the Caribbean, and to also take data from 50 existing GNSS stations that are in the Caribbean. Currently, 42 sites have been installed, or within the past, this is probably 3 months old. So 42 sites have been installed. We had a change in scope in that instead of creating new sites, we decided that we would spend money to refurbish existing sites. So now that we have 19 sites that have been refurbished, and we have contributing stations from more than 50, 61 sites right now. So with more than a year left to go in the project, we've exceeded our goal as far as the total number of stations. And finally, and at the end of the project, we will have more than 62 stations, new stations built, with the majority of the stations going now into Venezuela, the Lesser Antilles, Mexico, and a network of tide gauge stations that are kind of sparsely distributed in the Caribbean. And that will go into the refurbished sites and the existing sites. One interesting component of this is that the number of real-time sites that are streaming data for broader application now exceeds 35 stations. This is basically triple than what was proposed in the original proposal, and I think it is an example of how COCONet has been able to reach some pretty significant accomplishments. But there is a main component of this is how is really the international collaboration and capacity building going on, and that's what I want to talk about here. So the primary way that we initiated our contacts with our community was through 3 different workshops that were held. The first one was in Rio Grande, Puerto Rico, and it was basically a kickoff meeting where we were looking to establish what the community science goals were of the project, to have a first draft of where the station siting should go, and then to really focus on how are we going to best have our capacity building. We then transitioned to a workshop that was really focused on our siting committee, where we brought our international partners together in Port of Spain, Trinidad, and we really came up with the nuts and bolts of where stations are going, who are going to be the partners in the project, and who was going to help install and maintain these sites as we moved along. And then about a year and a half later, we were able to see that we were making project progress on the infrastructure, and we were able to take a look and then take a look at what the data products are going to be of COCONet and how are we going to support the research and the broader applications. So that was in October, and that basically established our connections, helped us form some new partnerships and move forward. One of the things that came out of all of this effort is that COCONet has been able to create a graduate fellowship program for researchers or students that are doing COCONet applicable science within the region. So there are currently 9 COCONet graduate fellowships at 8 different universities in the United States. They are all working on projects that have a COCONet theme to them at one level or the other. And if you'll notice that there's a pretty good diversity here. 5 of these 9 students are from regional countries, and so they are coming to the United States, gaining an education, learning about working on a project that is relevant to their area, and they will, at some level, go back to their regional community and help build the scientific infrastructure in the Caribbean. 2 other really strong educational components that have come out of this is separate proposals were written to fund Pan American Advanced Studies Institutes that were related to COCONet. One, which I helped organize, was on atmospheric processes of the Latin American and the Caribbean, looking at observations, analysis, and impacts. That was held in Cartagena, Colombia in May of 2013. And that was, I think, a really great project, at least in my opinion. We had 35 participants with 7 lecturers coming from 12 countries. So we had really diverse participation. It included lectures, it included computer labs, and group projects. I know of at least 4 of these PASI participants who are here at the AGU this year, and they have all said that that was a worthwhile experiment or project. And I'm happy to say that, one of these groups, we had to do these group projects, and we basically gave them a week to figure something out. And one of these projects expanded off of the workshop and has now been submitted for publication. And I think that is sort of a nice example of how that workshop moved forward. The second one was run by Peter Femina in Leon, Nicaragua, also in May of 2013, and it was similar, and it had 30 participants. They had lectures, they had field work instead of group projects, and they had computer labs. And so they were able to have hands-on sort of training on how to do GPS analysis. Bob King or Tom Herring, one of those 2, came down from MIT and gave a Gamut Globe-K workshop, and I think that was equally beneficial for that community. One major component on how open data and open data policies are being promoted throughout the Caribbean is the establishment of regional data centers, data and archive centers, and mirror centers. So there was an open proposal from the COCONet group to take proposals from regional centers to evaluate who could have a regional data center and a mirror data center. And so what UNAVCO would provide is they would provide computing hardware, all of the software related to UNAVCO's open archive, and training to these people. And what their benefits to these regional data centers is it would provide educational advancement, it would provide really professional development for archivists in the region. It will help prepare for hazard preparedness, response and mitigation development, and planning. And it will also help these groups understand living with Earth processes science. So there are 3 groups that were selected. The primary regional data center is the Colombian Geological Survey in Bogota, Colombia. They will have an archive that is basically a mirror archive of the UNAVCO COCONet archive, and they will allow them to include other data as they see fit within this archive. And I think that this is an example of if you promote open data and you give them the opportunity that they can take responsibility and they can have an infrastructure that allows them to distribute data in an open way. The other 2 places, the mirror centers, include the Caribbean Institute of Meteorology and Hydrology in Barbados and INITER in Nicaragua. One of the things that I'm most proud about is that we made a concerted effort to collaborate with all of our international partners. And as the primary example of this, in May of this year, we were able to jointly establish a continuously operating GPS station in Camaguey, Cuba. that was fully that was fully approved by the Department of Commerce through export licenses, the U.S. Full U.S. government approval, and also full Cuban government approval. This was a 7-year project in the making. There are articles in Science that have been written about this, and there's basically a historical summary of how are things going through that will be published either in this month or next month's Bulletin of the American Meteorological Society, basically describing how 7 years worth of interactions between Cuban scientists and U.S. scientists were able to build up a trusting foundation so that both groups were able to gain something out of this project, and I'm really quite proud of that. So all of the data are coming out of Cuba and are going to the UNAVCO archive and are made available for the broader research community. And I can use this. And so here's the station here on their atmospheric observing facility, and you know, they received a significant amount of training. And so as some of the examples of how this really active research group in Camaguey, Cuba, that doesn't have a ton of resources, how they were able to use the site. They were able to create a web page of using the observations that are going on that are basically available for anybody to go look at. They use the instrumentation there for calibration and validation studies for their sun photometer and their other instruments that they have going on. And in a novel way, what they were able to do is use the GPS receiver as an NTP server so that they could coordinate and synchronize their local computer network so that they can maximize their observations and synchronize the rest of their observations throughout their facility. So I think that it's a demonstration of how resourceful they are, and I'm quite proud of how this has moved forward. Again, there's been a lot of collaborators, partners in COCONet, and UCARS and collaborating. UNAVCO has done a tremendous amount of heavy lifting to make all of this possible. University of Houston, University of Puerto Rico, Mayagüez, and University of Texas, Arlington. And that doesn't, I don't mean to diminish, but there are also 25 really partners throughout the Caribbean who have really worked hard to make this project successful. So in summary, COCONet is a multidisciplinary project. I'm looking at natural hazards. At the end, it will have an infrastructure of more than 140 GPS stations, GPS stations, and that network was designed with significant feedback from our regional partners, so that it benefits them as well as the science objectives of the U.S. Scientists. About half of these sites will also have surface meteorology, making them really useful for atmospheric applications, and it's hard to understate how complex it is to install a network through 25 countries. Everybody has a different import-export problem. Everybody has a different communications problem. There are power issues. Some of these sites are on very small quays that are basically 1 foot above sea level that get, every time that there's high tide, it goes. And I'll just say that that's it. Okay.
Thank you.
I'm sorry.
Yeah, that's right.